Math 3, Unit 3, Section 1. Today we're talking about end behavior, and when we're talking about end behavior, we're talking about the end behavior of graphs. Okay, so far we've learned about our linear functions, we've had our absolute value functions, our exponential functions, and our quadratic functions. So sometimes we have functions that have different degrees, and these polynomial means many, poly, and so this is where it has different types of graphs. Okay, so the degree, does anybody remember what the degree is? Or you could read the definition. So the degree of the polynomial is basically just the highest exponent in the polynomial. So normally we have them written in descending order. And if you look at that first example, you're exactly correct. That answer for the degree is 5. If you look at the g of x example, do they have it written in descending order? No, but can you find the highest exponent in that problem? Good, 3. And then what would be the degree of the third example? 1. And so remember that this x, if it doesn't have an exponent, it actually has a 1. And so that degree is 1. Any questions there?
Are you looking to agree for all of them or just one specific?
So the degree of the problem is the highest exponent in that one. No, so f of x is one equation.
I know, but you got 5 for the second equation.
The highest exponent for f of x is 5, so the degree is 5. In this next problem, what is the highest exponent? Are we okay? Yeah. All right, perfect. Okay, leading coefficient. Okay, so this one was our degree, and then now we're moving on to our leading coefficient. So the leading coefficient of a polynomial is the coefficient of the term of the highest degree. So the leading coefficient is the number in front of our highest degree. So on this first example, what would be the leading coefficient?
3.
Very good. It's also important if you have positive and negative values. What's the leading coefficient on g of x? Good. And then on h of x? 2. Perfect. Okay. The end behavior, which is what we're talking about today, of the graph of a polynomial describes the values of f of x at the far right and the far left ends of the graph. Okay? So, if you notice on here, on the left side of the graph, it's going to negative infinity. On the right side of the graph, it's going to positive infinity. Here, both the left and the right are going to negative infinity. And all this should make sense because you guys remember what goes to negative infinity and so on. Here, the left is going to positive infinity, the right is negative infinity, and here both sides are going to positive infinity. So these are our options with our graphs. Okay? So this says, describe the end behavior of the following graphs. So right here, what is happening with each of these end behaviors? Both of them are going where? Very good. And so we're just going to write here, on the left and right, f of x goes to, and it's positive infinity, so we just write infinity. Okay, we are looking at the graph, which is really kind of like when you're looking at this, so you're kind of looking at more of the domain. Okay? Okay, what's happening on the second graph? Good. So on this one, on the left, f of x goes to what? Positive infinity. And on the right, f of x goes to what? Negative infinity. Okay, any questions so far? All right, we're going to move on to the next page. What? Okay, wait a minute. Okay. So on the next one, it has all these graphs for us, and yeah.
For the end behavior, do we have to write that whole sentence out? Can we just write positive?
So, good question. You could just write left positive infinity, right negative infinity, or L infinity, R, those things, yes. For the beginning, I kind of like you to write it out so that you understand, but as we move on through the unit, that's all I'll do. Okay. So, first of all, this first example, what is the degree?
3.
Very good. 3 is the degree. That comes from our highest exponent. Okay? The leading coefficient is the number in front of the highest degree, which in this case is 1. And my end behavior, in fact, let's go ahead and do this on these. We're going to do left and right for our end behavior, just like that. So on the left, it's going where? Negative infinity. And on the right, it's going to positive infinity. Okay, next example. What is my degree? 3. What is my leading coefficient? Okay, and on the right, it's going to, negative infinity, and on the left, it's going to positive infinity. It doesn't really matter which order we do left and right in. In fact, normally, we kind of should start with the right end behavior. It gives us more information later on, so I think I might just start going right and then left. Okay, what is the degree of this next one? 2. Leading coefficient is -1, and the right end behavior is negative infinity, and the left is also good. Okay, moving down. What is my degree on the next one? 4. Leading coefficient is -1, and the end behavior on the right and left is negative infinity. Am I going too fast? Okay, we're doing all this because we want to end up seeing a pattern. Like, when are the end behaviors the same? When are they different? When, like, what is happening? Because basically our degrees and our leading coefficients are they actually tell us our end behavior when we're graphing. And so the idea here as we go through here, that hopefully you're gonna notice patterns. Do some of you already see patterns? Okay, we're not gonna share them yet. We're gonna keep going. But as we're doing this, be thinking about what is the pattern, what is happening. Okay, so on this one, the degree is what? 5. The leading coefficient is 1, and my right end behavior is positive infinity, and the left is good. Okay, next one, degree is 4. Leading coefficient is 1. On the right and left, they're both going where? Good, positive infinity. Okay, moving down to the next row. What's my degree? 6. What is my leading coefficient? Good. On the right side and the left side, it's going where? Positive infinity. Okay, degree on the next one. 5. Leading coefficient. The end behavior on the right is going to negative infinity, and the left is good. Next one, degree is 2. Leading coefficient, right end behavior, and left end behavior. Good. Okay, last row here. What's the degree on the first, or this degree? 1. What is my leading coefficient? What is the right end behavior? Good. What is the left end behavior? Good. Okay, degree on the next one. 3. Leading coefficient, right end behavior, positive, left end behavior. Last one. What's the degree?
4.
Leading coefficient, right end behavior, and left end behavior. Okay, so the first thing I want you to think about is, it says the left and right end behavior of all even degree polynomials. So it's kind of leading you to think, okay? So go and look for all the even degrees And what do you notice about their end behaviors? Good. So that means that even degrees always go in the same direction. Okay, that is something you're going to have to remember. Okay, but it'll be easy as we go through it. So again, if you go back here and look at all these, each of my even degrees, they either both go negative infinity or they both go positive infinity. Okay, the left and right end behavior of all odd degree polynomials, what do you notice about the odd ones? Very good. They go in opposite directions. So now the next thing, it says the right end behavior. And so we are only, bless you, we're only looking at the right side. Okay, if you notice on here. So the right end behavior of all polynomials with a positive leading coefficient. Okay, so look at the positive coefficient, the leading coefficients for positive ones, and what does the right end behavior do on all those? Very good, they all go to positive infinity. So if the leading coefficient is positive, the right side goes to positive infinity. If the right end behavior with a negative leading coefficient goes to what? Negative infinity. Okay, so we always have to look at our leading coefficient first to decide, is it going to go to, on the right side, to positive or negative infinity? And then once you have that information, depending on the degree, the left side's either going to go in the same direction or the opposite direction. Okay, does that kind of make sense? Okay, so next thing, we have a chart here. Draw in and state the end behavior of each case. So we have a positive leading coefficient. So based on what we just learned, and let's just kind of like, we're not going to look at this right now, we're just going to look at these two. Positive leading coefficients, what happens to their right end behavior all the time? Positive infinity. So if you're drawing a graph, the right side for the positive leading coefficient will always go to positive infinity. Now, if it's an even degree, is this side going to go to positive infinity or is it going to go to negative infinity? Positive, because even degrees always go the same direction. And so that means when I'm graphing, that other stuff's going to happen in the middle. It could go up and down, it could curve, it could whatever, but no matter what, they're going to end up going up positive infinity on both sides if you have an even degree, positive leading coefficient. What happens with the odd degree here? It goes to negative infinity. So again, other stuff can happen here in the middle, but ultimately the left side's going to go to negative and the right side's going to go to positive. Okay, now a negative leading coefficient, my right end behavior is always going to go to negative infinity. So these sides will always go down to negative infinity. If it's an even degree, what will the left side do? Go down, good, because those will be the same. And then the odd one, it will go positive infinity up. So I remember odd degrees as opposite because O and O, odd opposite. Okay. And then for me, if it's a positive, it makes sense. I just have to remember if it's positive, right end behavior is positive. Okay, so positives, positive side. Okay, here we go. Identify the end behavior of this polynomial. So there's two things you always have to look at in order to determine the end behavior of the graph. One is the degree, and the other is your, I'm going to write it out this time, but it's your leading coefficient. Normally, I'll just put like LC and degree. So what is the degree on this polynomial? Very good. The degree is 3, and my leading coefficient is what? Good. And specifically, it really just means is it positive or negative, right? So my degree is odd, and my leading coefficient is 8. So on the right side, my right end behavior, what's going to happen? it's going to go to positive infinity. And my left end behavior, because the degree is odd, is going to go to negative infinity. Okay, and they want us to write some of these out in words. We're just going to write this one out and this one we won't, okay? So we would just say on the right, f of x goes to positive infinity, and on the left, f of x goes to negative infinity. Okay, 2. I'm going to give you about 30 seconds to decide what's happening. So we have our degree you need, the leading coefficient you need, and then based on that, you should be able to decide what is the right end behavior and what is the left end behavior. Okay, so I have 6 with your names on them, and so I'm just going to randomly call in some of you to help me. But before I do, I'm going to give you guys a chance in your group to talk about what you think the answers are, and then I'm going to call on some of you. Okay, you guys ready? All right, so my first question is, what is the degree of the polynomial? So, Aaron I, what's my degree?
6.
Very good, 6. And how do you know it's 6? So good job, Aaron, because 6 has the largest degree. Okay, leading coefficient. So, Suchi, what is my leading coefficient?
Sushi.
I didn't say Suchi. Suchi.
Sochi.
Sochi. Okay, I'm sorry. Forgive me. I'm sorry. Okay. You can have a candy if I say it wrong again. What is it? Perfect. And how do you know? It's the coefficient in front of the 6th degree. Very good. Okay. So, based on this information, what is my right end behavior? Destiny.
What?
Based on what we know with the degree being even and the coefficient being negative, do you know what my right end behavior is?
Negative infinity.
And how? Why? How do you know that?
Because it's a negative leading coefficient.
Exactly. We know the right end behavior is negative because the leading coefficient is negative. The right end behavior would be positive if the leading coefficient was positive. Okay, my left end behavior. Nia, what's my left end behavior?
Negative infinity.
Very good. And how did you know that to be true?
Because it's an even degree polynomial, so it's the same.
Perfect. I couldn't have said it better. Okay, is everybody good with that? All right. Okay, moving on. Nicely done. Identify whether the function graph has an odd or even degree and a positive or negative leading coefficient and justify your answer. When they say justify your answer, that means write out in words. We're just going to write out in words one problem, okay? So, number 3, we're going to talk about this one and write it out. So, what do you think the leading coefficient is? Okay, so we have leading coefficient and we have our degree, correct? Okay. Good. So the leading coefficient is going to be negative. How do we know it is negative? Because the right side is going to negative infinity. Good. Okay, what type of degree will I have? Very good. I'm going to have an odd degree. How do I know that it's an odd degree? Very good, because they're going in opposite directions and odd degrees go in opposite directions. So now we need to write this in words, what we just said in words. Okay? And so the leading coefficient, and I'm just going to put LC to save myself a little bit of time. The leading coefficient is what? Negative. Because why? Good. Because the right end behavior, I can't spell behavior right now. Okay, there we go. Ish. Behavior is what? Yeah, or the right end behavior is going to negative infinity. Okay, we need one more sentence. The degree is what? Odd, because why? Because the end behavior is going in opposite directions. So, number 4, we're not going to write it out in words. Okay, we're just going to do that one time. Number 4, I'm going to give you about 30 seconds or so. You need to figure out what's the leading coefficient, negative or positive, and is the degree even or odd. So based on everything we've been talking about, you could even go back to your chart. Looking at your end behaviors, you should be able to decide if it's negative or positive and odd or even. No, you're just saying one or the other. See right here, odd or even degree, positive or negative coefficient. Okay, I'm going to give you about 10 seconds to talk in your groups, discuss your answers, and then I'm going to pull some more sticks here. Okay, here we go. So, leading coefficient. My leading coefficient, Noah, is going to be what? I mean, Tiger. I'm sorry.
It's going to be positive.
Good. And how do you know?
Because they're going in the same direction.
Very good. Well, specifically, actually, we know it's positive because the right side. So, leading coefficient is always talking about the right side. So, leading coefficient is positive because the right is positive infinity. So, that's going to be our written work there. And my degree on this function is what, Taylor?
Even.
Good. And specifically, we know it's even because...
They're both going in the same direction.
Very good. Same direction is how we knew that one. Does anybody have questions there? We're good? Okay. Example 5. Give an equation of a polynomial with n behavior of, on the left, f of x goes to negative infinity, and on the right, f of x goes to negative infinity. Okay. So on the left, if it's going to negative infinity, and on the right, it also goes to negative infinity. I'm just going to write it up here. What do we know about the leading coefficient and the degree? Okay, the leading coefficient is going to be what? Positive or negative? Negative. How do we know it's negative? Good. Right is negative infinity. That's how I know the leading coefficient will be negative. What degree will it be, even or odd? Even. How do we know the degree is even? Good. Both. I'm just going to put both the same, or whatever you want to write that makes sense to you. So there are multiple answers here. Okay? So I'm just going to write, because they're saying f of x, so I'm going to go f of x equals, my leading coefficient needs to be negative, and my degree has to be even. So I could go negative 3x to the 4th, and then you could make up anything else here. Or I could leave it just this way. Or I could put plus 2x to the 3rd minus x squared plus x plus 1. But ultimately, none of this matters. The only thing that matters is that the degree is even and the leading coefficient is negative. And all the rest of it doesn't really matter. And you can make up any number. So you could have had a negative 1 here. You could have had a negative 5. You could have had a negative 726. I don't know. Okay? So any number. Okay? Same thing with the degrees. Are there other even degrees besides 4? Yeah. You could have had what? 2, 4, 6, 8. Okay? Yeah, I was hoping you would finish that with... Never mind. Okay. So do we have any questions about this? So if I was checking your work on this, the only thing I'm going to be checking is that the leading coefficient is negative, the degree is even. Please do not be on your cell phones right now. Okay, so number 6. Give an equation for g of x this time. So when we're writing our equation, we're going to write g of x with end behavior on the left side going to negative infinity, and on the right side it's going to positive infinity. And I just want it right there on the same spot. So you need to figure out what your leading coefficient is and what your degree is. I'm going to give you a chance to try this on your own. Bless you. Okay, so talk in your groups, and then I'm going to pull some sticks for some help. Okay, give me a thumbs up if you're ready. Okay, so leading coefficient. He's not here. Mallory, what would be my leading coefficient? Positive or negative? Very good. And how did you know my leading coefficient is positive? Very good. The right is positive infinity. That's how I know the leading coefficient is positive. Good. Okay, so my next question is, what is my degree? Colton, what's my degree?
Odd.
How do you know?
Because it starts negative and goes positive.
Very good. So that one is opposite directions, you know, for your end behavior. Good. Okay, now the next stick is I just want somebody to give me an example of what my equation could be. So we know it's going to be g of x, and then based on this information, give me some terms or a term. Okay, are we ready? Caitlin.
5x to the 7th.
Perfect. And you don't even have to write anything else. That could be your whole equation. Is the leading coefficient positive? Yeah. Is the degree odd? Yep, that's it. She's done. Could she have added more if she wanted to?
Yeah.
Yes. Okay. Questions? All right, let's turn the page. So these last two examples, they just want you to try to sketch a graph with a positive leading coefficient and an even degree. So, based on that information, okay, my right side, because I have a positive leading coefficient, what do I know about my right end behavior? Good. So this tells me that the right side is going up or positive infinity. So on the graph, I'm just going to go like this to start myself off. Because it's an even degree, what do we know?
That the other side's going to be positive.
Same direction. Very good. So what that means is that over here, this is also going to go to positive infinity. In the middle, you can do whatever you want. Okay? I don't know what I did, but that's something. Okay? So you can draw whatever you want to in the middle, but it just has to end going in positive infinity both directions. Could you have just drawn a quadratic function? Yeah. Okay, number 8. Sketch a graph with a negative leading coefficient and an odd degree. Negative leading coefficient. What does that mean? What does that tell me? The right side is going to down, negative infinity. Since it's an odd degree, what does that tell us? Good, opposite directions. Okay. Based on that information, why don't you draw a graph? Would anybody like to come up and draw one? Okay, Lavina. Good, so the right side she drew is going to negative infinity. On the left side, it's going to end up going to positive infinity, and then she is just going to draw a graph in between. Perfect. All right, do we have any questions? All right, we are done. You guys did a great job, so let me look at your homework to reduce it. And even though it was 4 pages, it wasn't that bad. Stop it. Oh my goodness, thank you.